Good afternoon to all. So in last lecture, anemometer point is completed. In that, two subtitle is there: constant temperature method and constant current method. Okay. So today we are going to start new point, turbine meters. Okay. Basically, the turbine meter are used to measure the flow rate. Means turbine meters or flow meters are used to measure the flow rate of liquid or gas. Okay. Turbine meters or flow meters are used to measure the flow rate of gas or liquid. Okay. So this is turbine flow meter in a volume sensing device. As liquid or gas passes through the turbine housing, it causes the freely suspended turbine blades to rotate. The velocity of turbine rotor is directly proportional to the velocity of fluid passing through the flow meter. See the velocity of turbine meter is directly proportional to the velocity of fluid passing through this flow meter with the help of blade, rotor blades. Okay, the flow meter or flow sensor is an instrument. It is used to measure linear, non-linear mass or volumetric flow rate of liquid or gas. Okay. So write down give the heading turbine meters and write down two sentences in that turbine meter. A turbine meter is an instrument used to measure linear, non-linear, mass or volumetric flow rate, of liquid or gas, of liquid or gas. Okay. Then types of flow meters. Give the heading types of flow meters. Types of flow meters. In that, calories meters, write down, magnetic meters, multi-phase meters, turbine meters, ultrasonic meters, vortex meters, and last one is positive displacement, PD flow meters. Our syllabus only positive displacement PD flow meter is there. Okay. These are the types of flow meters: calories meter, magnetic meters, multi-phase meters, turbine meters, ultrasonic meters, vortex meters, and last one is a positive displacement PD flow meters. This is positive displacement PD flow meter in our syllabus point. Give the heading positive displacement meters. Okay. Give the heading positive displacement meters. Then first point is that what is mean by positive displacement? Okay. What is mean by positive displacement is that flow is directly proportional to the output of the flow meter or turbine meters. Means positive displacement moves a fluid repeatedly enclosing a fixed volume and moving it mechanically through the system. Moving it mechanically through the system means mechanical systems are used in that screw, gears, rollers, diaphragm or vanes. Basically, pistons, cylinders are used in positive displacement flow meters. Okay. So here positive displacement flow meter are the only measuring technology to directly measure the volume of fluid that passes through the flow meter. Means positive displacement meter are basically used to measure the flow of fluid or liquid passes through the flow meter. Okay, it achieves this by trapping pockets of fluid between rotating components housed within a high precision chamber. Means in flow meter, liquid means liquid or gas passes through the flow meter with the help of turbine blades. In that turbine blades, small pockets are attached with high precision chambers, and these high precision chamber pockets measure the flow rate of the fluid. Okay. Also, positive displacement flow meters are used to measure the volumetric flow rate of moving fluid or gas by dividing the media into fixed or metered volume. Okay. There also basic analogy would be holding a bucket below a tap filling in the set level, then quickly replacing it with another bucket and timing the rate which is the buckets are filled, total number of buckets to the totalized flow. Basic concept is that of positive displacement meter is you have to use one bucket and place in below the water tap and check the how much time to take to fill this bucket, and then continue checking the 2 3 buckets and check the timing. Then you have to calculate the flow rate of this tap. With appropriate pressure and temperature compensation, the mass flow rate can be accurately determined. This is the overview of positive displacement meter. Okay. See, one example of positive displacement meter, piston pumps. Okay. So I request all of you to draw this diagram, piston pump, under the heading positive displacement meters. Give the heading positive displacement meters. Then draw this diagram. Give the heading piston pumps. This is the construction and working of piston pump under the heading positive displacement meter. Okay. In piston pumps, see the two diagrams is there. One is a suction, second is a discharge, means compression. In this diagram, when motor pulls the piston out, here this piston out, then inlet valve is open and outlet valve is closed. Okay. When motor pulls the piston out, in that inlet valve is open and outlet valve is closed. Then second diagram, discharge or compression. Okay. When motor pushes the piston this side, inlet valve is closed and outlet valve is open. These are these piston heads. Here seal will be there for leakage purposes. Okay. So positive displacement pumps. Okay. It is constant flow rate against the wide range of discharge pressure. Okay. Means you have to motor pulls these pistons. This area will be fixed. So absorption of liquid or fluid is constant, means constant flow rate. And when the motor pushes this piston this side, outlet valve is open. Again, this constant flow will be passes with the help of outlet port. Okay. So this discharge of pressure in measure the pounds per square inches, means psi. psi, pound per square inches, or also pound per square inch absolute. They are used to clear that the pressure is relative to the vacuum rather than the ambient atmosphere. Okay. These diagram are only used for understanding purpose. Okay. Here write down the what is mean by positive displacement meter. Under this diagram, write down 2-3 points. Okay. Positive displacement flow meters measure the volumetric flow rate, measure the volumetric flow rate of a moving fluid or gas by dividing the media into fixed metered volumes, fixed metered volume. Okay. Full stop and next line. PD flow meters are used to measure the volume of fluid that passes through the flow meter. That passes through the flow meter. Full stop and next line. It achieve this by trapping pockets of fluid between rotating components housed within a high precision chamber. Okay. This is the positive displacement meter. Then next point, give the heading differential pressure flow meters. Differential pressure flow meters. Okay. The difference between the positive displacement flow meter and differential pressure flow meter is that in positive displacement flow meter, uh, flow rate of fluid or liquid is constant, and in differential pressure flow meter is that flow rate of fluid or any fluid or gas, means liquid or gas, is varies. This is the main difference in between positive displacement flow meter and differential pressure flow meter. Okay. So differential pressure flow meters are basically used to measure the volume flow in gases, liquid and steam. Okay. In that potential positive displacement flow meters are used only liquids, and differential pressure flow meters are used to measure volume flow in gases, liquid and steam. Okay, they are particularly used in situation where high pressure, high temperature or a large diameter play a role. Means where that high pressure and high temperature is here, their differential pressure flow meters are used. Okay, they are mainly found in the chemical, oil, gas and power industries. Means applications of differential flow meters are, they are used in mainly chemical, oil, gas and power industries. Okay, so differential pressure or dp means differential pressure, simply the difference between two applied pressures. For example, if pressure at point is equal to 100 psi, pounds per, and pressure at point B at 60 psi, then difference between 40 psi, 100 psi minus 60 psi. This is the difference of two different points A and B. Okay, common method to measure the flow of differential pressure meter is the differential pressure across the orifice. Here orifice or uh, orifice plate are used. This see the next diagram here. In that, here orifice plates are used. Here direction of flow, and here difference, here to measure the flow. See the volume of this section, volume of this section, and here volume of this section. Here one pressure meter is used, here one pressure meter is used. Here you have to measure the pressure, and then here you have to measure the pressure, and this difference is the differential pressure meter. Means this is 100 psi and this is 60 psi. Consider that. So 100 minus 60, the difference is the 40 psi. This is one diagram and this is second diagram. Okay, here differentials are used and here orifice plates are used. See the volume of this pipe, then here orifice plates are used, then this orifice plate, here a differential pressure transmitter is used, and here indicator is used to display the pressure. Here you have to check the pressure, is that here this achieve this differential pressure meter and transfer with the help of these wires and meter. Then here second Vena contract are used to measure the pressure after passing the fluid to the orifice. Okay, so under the heading, give the heading differential pressure flow meters. Give the heading differential pressure flow meters and draw this diagram within 5 minutes. Draw it fast. So in, okay, differential flow meter, write down 2 3 point of under the differential flow meter. The differential pressure flow meter measures the volume flow in gases, comma, liquids, and steam. Then next line, they are particularly used in situations where high pressure, high temperature, or a large diameter play a role. Full stop. It is mainly used in chemical, comma, oil, comma, gas, and power industries. It is mainly used chemical, oil, gas, and power industries. Okay. Then write down differential pressure is measured in Pascal, PASCL, in Pascal. Pascal means Newton per meter square. Newton per meter square. Okay. Full stop and next line. Write down. To find the velocity of fluid flow, to find the velocity of fluid flow, multiply the differential pressure by 2 TW and divide this number by the density of flowing material. Density of flowing material. The most common method, full stop and next line, the most common method is to measure the pressure drop across an orifice plate in the pipe and calculate the flow rate. Next time, pressure differential does affect the flow. Pressure differential does affect the flow. Then the flow is directly proportional to pressure differential until the fluid reaches critical velocity. Until the fluid reaches critical velocity. Full stop. And next and last point of this chapter, mass flow meter. Okay, give the heading mass flow meter. Mass flow meter. Here, mass flow meter are basically used to measure the flow rate of fluid traveling through the tube. Means where the fluid is traveling in the tube, there you have to measure with the help of mass flow meter of flow rate of this liquid. Okay. Here, draw this diagram: variable area flow meter and fixed area flow meter. Draw these two diagram: variable area flow meter and fixed area flow meter. Draw only these two diagrams: variable area flow meter and fixed area flow meter. Okay. See the mass flow meter. Mass flow meter. Basically, mass flow meter are used to measure the flow, which is flow transferring to the tube. Here, mass flow rate of fluid traveling through the tube. Here, this is evacuated tube is there. Flow transfer in that fluid. When pressure is increased, fluid pressure is increased, this tube will get oscillate. Means see the twist angle. Here the axis is the twist angle. This is the twist angle. Means flow reaches is high pressure, then this tube will get oscillated. Okay, and you have to measure the this oscillation, then complete loop twisted by an amount that directly and linearly to the mass flow rate of the fluid. Okay, and here variable area flow meter and fixed area flow meter. Here this differential manometer are used. Means mercury. This blue content is mercury content. Here mercury level is there. Then see the first diagram, variable area flow meter. In variable area flow meter, this flow is passing through that way, and here in that float is attached. Float means hurdle or disturbance in the flow. Then you have to measure this pressure in here. Then mercury level will get increased, and you have to check this pressure here. Then mercury level will be decreased, and measure the difference between here to here. Means you have to measure pressure. Here will be pressure will be high, and here pressure will be reduces. Means you have to consider here 100 psi and here 60 psi. Then you have to measure 100 minus 16, 40 psi pressure difference. And here fixed area flow meter. Here area will be difference. See this area and see this area. Means this is very small, and here area will be increased, enlarged. And here fixed area flow meter, continuous flow will be passes with the help of these orifice plates are fitted or put in this flow meter. Then you have to measure here the initial pressure, here initial pressure, and then after passing this flow with orifice plate, then you have to measure the here pressure, and you have to check the difference between this pressure. Okay, so in mass flow meter, it is a device is used to measure mass flow rate of fluid traveling through the tube. Means basically mass flow meters are used to measure the flow rate which is fluid traveling through the tube. Where it is fluid traveling through in tubes, that mass flow meters are used. Okay, the mass flow rate is the mass of the liquid traveling past a fixed point per unit time. Write down 2-3 points under the mass flow meter. It is a device that measure mass flow rate of fluid traveling through a tube. Traveling through a tube. Next line. The mass flow rate is the mass flow rate is the mass of liquid traveling past a fixed point per unit time. Next line. That does not measure The volume per unit time, that does not measure the volume per unit time passing through the device. They measure mass per unit time. Measure mass per unit time means kilogram per second flowing through the device. Flowing through this device. Full stop and next line. Volumetric flow rate is the mass flow rate. Volumetric flow rate is the mass flow rate divided by the fluid density full stop. If the density is constant, then the relationship is simple. Full stop and next line. The density of fluid may change with temperature, pressure, or composition. The density of fluid may change with temperature, pressure, or composition. Okay. So today stop here. Place your roll number and leave the meeting.